All right, good evening, parents. I think you might have to click through this PowerPoint. I'm going to try to record it one more time. This is my third take. The first time was the best. You should have seen that one. But anyway, parents and students, this is how we calculate protons, neutrons, and electrons uh, from the information given to us on the periodic table. And we've been working on this for about a week and a half now. And I have given a pop quiz, and some kids had some issues with certain areas. It was a way for me to see who was struggling. We had a session of small group work a couple of days ago where I sat down with a group of students who really struggled. We went through it, reworked it, they corrected their quizzes, and we did the average of the two, so that grade will go up in the grade book when I put it in there, hopefully later tonight. And I just want to share it with you because I know some of you are very involved, which is great, and you might have some questions. Whoops, I didn't mean to do that. So here we go. Okay, this slide right here is what the problem looks like. So if you'll see that on the thing they have a box, and the box is reminiscent of what would be on the periodic table. On the top they have the atomic number, then they have the symbol, then they have the name, then they have the atomic weight. Sometimes I'll leave this blank or this blank, and I give them a laminated copy of a periodic table. From that information, looking for the atomic number or the piece that's missing or that's there, they can fill in the blank. So sometimes they'll have to do that. And they've all figured that out and do that quite well. And I think I have to turn this off real quick. So at the top, they have an atomic number, and the atomic number is 53 in this case. So all they have to do for the first step underneath is they have to write 53. So that's pretty easy. Just record the atomic number next to the thing that says atomic number, which is funny because some of them don't know that that is a number sign. I call it a hashtag. It's amazing how time has evolved here. Nobody knows what the pound or number sign is anymore. So the next thing they have to do is they have to round this number. And this is the most difficult thing for many of them. Excuse me while I pull out my pen here. So they have to round the number, and what happens is they have a terrible time doing this. And unfortunately, this was something that they have covered in 5th, 6th, and 7th grade math. But they still struggle with rounding. And rounding isn't that hard. I tell them to think of it as money. So 126.90 is like $126.90. Of course, this third decimal would throw them off. But is the $126.90 closer to $127 or $126? Sometimes that helps, sometimes it doesn't. The standard rule is, of course, we're trying to get rid of these decimals because we don't want to deal with them. So we want to round to the nearest whole number right here. So here's the number we're rounding to. We want to look at this number right here. This number is 9. If this number were 5 or greater, we have to add 1 to this, so we make it 127. If this number were lower than 5, 4 or lower, then we would keep it the same. So we're either keeping it the same or bumping it up a 1. So what are we going to do? I always say to people, are we keeping it the same or are we bumping it up? Now, that isn't that hard. And so this answer should be 126 or 127. And frankly, if they can't round it, but they keep it the same, I usually don't take a point off. But for some reason, rounding has become adding these two numbers together. I don't know, making up a number. I'm not really sure. So what I'm looking for here is ideally 127. If I got 126 here, I probably wouldn't take any points off. But if I end up getting 407, then I know we have a serious problem. All right, so the next thing we would do is we have to write down how many protons, neutrons, and electrons there are. But what's great is the protons and the electrons are equal to the atomic number. So I tell them there should be 3 numbers that are the same. The number on the top of the box is the number under atomic number, of course, and it's also the number of protons, and that's a beautiful squiggle. It's also the number of electrons. Protons and electrons are the same because protons are positive and electrons are negative, and the positives always have to equal the negatives because this is a no-charged atom. It's just a neutral atom, so it's equal. All right, so that's the toughest. All right, so well, next to rounding, it's the toughest. Now, if we've rounded correctly, then we have the correct number here. If we have not rounded correctly, then we might have a 126. If we have really not rounded correctly, we have like 407, and that becomes really bizarre, and I don't know how to fix that except to say, what the heck did that happen? Sometimes I can figure out where that number came from, sometimes I can't. Do not guess, I tell them. Do not make up a number. This number is just the rounded form of this number. All right, so all we have to do then is, if we have these numbers correct, we take the atomic mass number and we subtract the atomic number. They can use their calculators. They are provided calculators. There's some in the classroom. They type 127 minus 53 and they get the answer. It's 74. The number of neutrons is not necessarily the same as these two. The number of neutrons is sometimes different. Sometimes it's the same, but you can't just guess. You have to take the big number minus the little number. And sometimes I will put that on the board, B minus L, so that you might see me writing that on their quizzes. Big number minus little number. There should be two numbers on the page, the big number and the little number, and they would subtract that, and that's what they would get. Sometimes kids add these together and put that there. I never say add. The only time I would say add is not in this case, not on these kinds of problems, but these two numbers, the protons and neutrons, added together should make up the atomic mass, because that's the nucleus of the atom. The nucleus of the atom contains the protons and the neutrons. That's the big mass. I tell them to think of a starlight peppermint surrounded by cotton candy. The starlight peppermint, if I threw a starlight peppermint surrounded by cotton candy at you, you would feel the bump from the starlight mint, and the cotton candy would just be sticky fluff, because the cotton candy is this cloud of electrons, hardly any mass at all. The mass is in this nucleus, which is made up of these two things together. All right, that's all I have to say about that. That's what their answer should be, and that's how we got it. I hope that clears up for some of you who are trying to help desperately with your little children. And they're doing quite well. They're getting better.